In the next two videos, we will talk about combining datasets. Often data comes from different data sources, and to be analyzed, this data needs to be integrated. Pandas offer two conceptually different operations for combining datasets: concatenation and joining. The big difference between concatenation and joining is that in concatenation, doesn't check for data validity. It's kind of like sticking datasets together without paying respect to the values in these datasets. Joining, on the other hand, combines the data by paying respect to the values of the data. It's kind of similar to joining data in databases. In this video, we'll talk about concatenation. First, we're going to define a function called makeDF. Now, this function just creates a data frame from a list of columns and a list of rows here, so we get a kind of hypothetical data frame to play with. We are going also to define another function called display. This function is a helper function so that data frames show side by side. This function is completely not related to concatenation. We don't need the function to perform concatenation. It's just to improve the displaying of multiple data frames so that they show side by side. Let's start by looking at concatenation with series. We have here two series, series 1 and series 2. Series 1 is ABC and series 2 is DEF. The index of series 1 is 1, 2, 3, the index of series 2 is 4, 5, 6. Now, if I concatenate series 1 and series 2, what's going to happen simply is that series 2 will be stuck after series 1, hence the name concatenation. This operation doesn't pay any respect to the index. Say there is a common index here, that doesn't change how things operate on the value. You're basically taking the first series and you're sticking the second series after the first series, regardless of the values of the index and the values of the values themselves. Let's take a look at this example with a data frame. In this example, we have two data frames, df1 and df2. df1 and df2 share the same column index, but they have a different row index. Now, concatenation, simply speaking, will basically put df2 after df1. This is kind of very similar to what we had in the series. We're simply sticking df2 here after df1. And again, this doesn't pay any respect to the row index of the data frame. Even if df2 had exactly the same index as df1, we're going to have that index here repeated. Pandas is not going to try to match anything across this index. On the other hand, pandas will try to align the data appropriately because the data frame 2 has the same column index AB as data frame 1. It makes sense to list the values of data frame 2 on the A column after the values in data frame 1 on the A column and the ones on the B column after the ones on the B column. This process is aligning the index. We did not have this problem with a series because the series only has one axis. So when we are concatenating a series, we're concatenating series on one axis and there is no need to align anything here. We're basically putting values of series 1 after the values of series 2. Series 2 after the values of series 1. Well, the data frame has two axes. There is the row axis and the column axis. And by default, when we're concatenating row-wise across the row axis. When we do that, pandas will align the other axis. Let's take a look at an example here to make this case clear. Let's say in this example here, I'm actually going to create another example here. Let's do the same example, but instead of having df2 being AB, I'm going to make df2 being B and C. Now what we have here, we have the concatenation of df1 and df2, and you notice that for df2 the values in the B column were aligned to the values in the B column of df1, which is this part. However, the values in the resulting data frame in the part belonging to data frame 2 that doesn't align to the part of df1 is null values, and similarly speaking, the part in df1 that doesn't align to df2 is null values. That's because df1 doesn't have a C column and df2 doesn't have an A column. So to recap what's going here under the hood, when we're concatenating two data frames, we are deciding the axis on which we want to do the concatenation. By default is going to be the row axis. So pandas will basically list the values of the second data frame on the row axis after the values of the first data frame on the row axis, but it's still going to try to align the other axis, which is the column axis. If it aligns, perfectly, if it's the same columns, there is no issue. I mean, the resulting data frame will have the same column index. If it doesn't align, you will get null values in the places where it doesn't align. Let's do this third example here. Here I'm going to make df2 completely having a different column index. I'm going to do C and D. Now if I concatenate now, you can see that the concatenation resulting in a data frame where you have null values in the places that don't align. Now you can see that the alignment here is trying to preserve the meaning, the semantics of the operation, because A and B are different than C and D, so it doesn't make sense to put C3 under A2 or C4 here in this cell here. You get a null value. This warning message we are getting is because we have a concatenation and the axis is not completely aligned. And pandas is just telling us that it's sorting it, but in the future it may not sort it. We may not get A, B, C, D, so this is something we may need to enforce if we wish it to be sorted. So by default, when we are concatenating two data frames, we're concatenating across the row axis. If we want to concatenate across the column axis, we simply need to provide the axis argument here to be columns. Let's take a look at this example. Here we have two data frames. They have the same row index, but they have a different column index. And if I concatenate df3 and df4 across the columns, I'm simply going to stick df2 after df1. But I'm sticking df2 after df1 on the column index. Now notice, because the row index completely aligns, I don't get any null values. Let's repeat this operation again when the row index doesn't align perfectly. Let's do this. Let's do, for instance, 1 and 2. In this case, you can see here that df3 has a 0 and 1 as a row index. df4 has 1 and 2. So when we stick them together, we're going to align the rows that share the same row index 1. The rows that do not align will be there, but you will get null values in the corresponding places of the other data frames. Now, when we're looking at the axis, which we're concatenating the data frame across, we've actually seen that pandas doesn't do any checks. For instance, if we have a duplicate index, pandas is not going to worry about the duplicate index here at all. For instance, let's do two data frames here, x and y, and let's make them share the same index, 0 and 1. If you're concatenating both of them, you can see that the index has been repeated. Now, this may or may not be what we want to do. Maybe we want to signal an error because maybe we were expecting the duplicate index to have a certain meaning that we want to preserve or do some validation check. By default, pandas doesn't do any validation check, but we can actually provide another parameter called verify integrity. This parameter, if we provide, is going just to throw an error if we're trying to concatenate two data frames or two series in which there is an overlap in the index across the axis we're concatenating. We can catch this error and we can respond to this error depending on how we want to respond with it. The other extreme is to basically throw the index completely and re-index the resulting data frame. Meaning I don't really care about the row index and I don't want it to be repeated. I'm going just to re-index the resulting data frame. If I pass the parameter ignore index to be true, that's simply going to happen is that we will get another index going from 0 to length -1. Another option is to create a multi-index, saying that, well, the index overlap here, so when it overlaps, we're going to add another level in the resulting index, and the parameter keys allows us to specify the names of these levels for each one of the data frames. So we can specify that X and Y to be the keys, and now when we get a new data frame and a new data frame resulting from the concatenation, we have a multi-index. This is useful if those data frames, for instance, are representing same observations, for instance, across different department, different time period. We can preserve this information as another level in the index. For instance, let's say this is information about client in department X and this is department Y. We still have department X and department Y here. Next, let's talk about some other options we have when we do the concatenation. So once again, to summarize the operation, when we concatenate two data frames, we specify the axis across which we're concatenating. The other axis will be aligned, and in the places it doesn't align across the two data frames, we get null values. Now, pandas provides option if we don't want to have these places that don't align in the resulting data frame, the result of the concatenation operation. Now, this is completely different from joining two data frames that we will see next time. This is basically specifying whether we want to see these null values or not. So let's take a look at this example here. In this example, we have two data frames, df1 and df2, and you can see here, if you take a look at the column index here, there is an overlap, ABC and BCD. Of course, the row index we don't really care about if we are concatenating across the rows. When we concatenate these two data frames, we're going to get null values here in A in the second part and in D in the first part, because the data frame 5 doesn't have a D column and data frame 6 doesn't have an A column. If we only care about the parts that do align across the column axis, we can provide a parameter called join. If I specify join to be inner, then simply speaking, we're going to drop columns A and column D from the resulting data frame, meaning caring only about B and C. Once again, this doesn't mean we're joining the two data frames. Still, it's a concatenation operation that doesn't pay any respect to the values in the two data frames. We're only caring about whether we want to keep part of the column index that is not overlapping or not. We can also specify if we want to keep only part from the left side or the right side. We can provide another parameter called the join axis. Say for instance, I only want to keep A, B, C, although there is null values in A, but I don't want to see the null values in D. I can definitely do that. I can do pd.concat df5 and df6 and join axis df5.columns. And what I get a data frame, which is the concatenation operation, but it only keeps A, B, and C. Finally, pandas provide a quality of life function called append. In contrast to concat, which is a function that you call on the package and provide a list of the data frames that you want to concatenate, append is a function that we call on the data frame itself. Now, append doesn't have many bells and whistles such as concat. It basically concatenates the two data frames row-wise on the row axis, and you call it on the first data frame. So we do data frame 1 dot append data frame 2, and we get the concatenation here. So this quality of life function is simply because most of the time that's what we want to do. We want just to stick one data frame after the other data frame. So we do data frame 1 dot append data frame 2. So to summarize, concatenation and appending is basically sticking series and sticking data frames after each other. In the case of a series, it's very straightforward because there is only one axis. In the case of two data frames, it's a bit more difficult because we have two axes. So we have to choose one axis on which we want to do the concatenation operation, and by default it's the row axis. The other axis is going to be aligned, and we will get null values when it doesn't align. And there are other parameters that we can provide in order to specify how we want to do with the index of the resulting data frame, as well as part of the other axis that doesn't align when we do the concatenation operation.